Welcome back to this channel, students. We were dealing with the chapter Some Basic Concept of Chemistry. Today we will learn about a topic called as percentage composition, also called as percentage formula, or it is called as mass percentage. So today we will learn about this topic, that is percentage composition. So let's begin with understanding what is the meaning of percentage composition or percentage formula or mass percentage. Let's take example H2O. We all know what is H2O, that is nothing but water. Let's imagine I tell you I want to know the mass percentage of oxygen in H2O. Or one more question, I want to know the mass percentage of hydrogen in water. So how to find out the particular percentage composition or percentage formula or the mass percentage of a particular atom or element in a compound is identified by giving one formula, that is formula to calculate mass percentage of a particular atom or element in a compound. It is given by, this is important, mass percentage of an atom is equal to number of atom. It is nothing but a particular, whatever atom you are finding, how many atoms are there in that particular compound. Number of atoms in one molecule, atomicity of this particular atom divided the molecular mass of the compound into 100. Hope you all know what is molecular mass. Molecular mass is nothing but sum of atomic mass. For example, we have H2O. How to find out the molecular mass? I'll denote it as mm of H2O. We have 2 hydrogen into the molecular mass of the atomic mass of hydrogen is 1. Put that in bracket plus how many oxygen we have? We have 1, and atomic mass of oxygen is 16. It's given by 2 plus 16 is equal to 18. The molecular mass of H2O is 18 grams. Is it clear? This is nothing but, let's imagine next example, CO2. So molecular mass of CO2 is, how many carbons we have? We have 1 carbon. What is atomic mass of carbon? Into 12 plus how many oxygen we have? We have 2. What is atomic mass of oxygen? That is 16. So 12 into 1 is 12 plus 32. So we have 44 grams. This is the molecular mass of CO2. Is it clear how to find out the molecular mass? Nothing but sum of atomic mass. This is number of atoms. This is atomic mass of particular atom. Let's see one example. Calculate the mass percentage of hydrogen in water. They are asking the mass percentage of hydrogen. How to find out? Put the formula. Mass percentage of hydrogen atom is equal to number of hydrogen atom into atomic mass of hydrogen divided by molecular mass of H2O, and it is mass percentage, so into 100. Number of atoms, how many atoms we have here? 1. What is atomic mass of hydrogen? Number of atoms we have here is hydrogen, we have 2, so it is 2 here, and atomic mass of hydrogen is 1 divided by, we have already counted the molecular mass of hydrogen, that is 18. So molecular mass of hydrogen is 18 into 100. So if we calculate, the answer that we get is 11.11 percentage of what? Of hydrogen is present in H2O. Is it clear how to find out percentage composition of particular atom? By this simple formula. Let's see next formula. Pause the video and solve it and cross check the answers, students. Calculate the mass percentage composition of oxygen. Now they are asking oxygen. So again put the formula. Mass percentage of oxygen is equal to number of oxygen atom into atomic mass of oxygen atomic mass of oxygen divided by molecular mass of H2O into 100. So it is given by number of atoms of oxygen, we have only one. Atomic mass of oxygen is 16 divided by 18 into 100. Calculate and tell me the answer, or you can comment down below. So it is 88.88% of oxygen present in water. Is it clear? Now let's see few of the KCET based question. That is, first one, calculate the percentage of deuterium in heavy water. So what is deuterium? This is an isotope of which element? Hydrogen. And what is isotope? That they have same atomic number but different atomic mass. Hydrogen has 3 isotopes, that is 1H1, 1H2, 1H3. 1H1 is called as protium. It has mass 1. Next it is called as deuterium. The mass is 2. And tritium, the mass is 3. So they are asking the percentage of deuterium in heavy water. Heavy water has molecular formula, or the chemical formula of deuterium is D2O. D is nothing but here, the D is nothing but deuterium. So they are asking the mass percentage of deuterium. So let's calculate. Let's write the formula. Mass percentage of deuterium, D, is equal to number of deuterium atom into atomic mass of deuterium into 100 divided by molecular mass of D2O. So now number of atoms of deuterium is 2 into deuterium atomic mass. Atomic mass is how much? 2 divided. How to find out the molecular mass of D2O? The molecular mass of D2O is, we have 2 deuterium into, what is atomic mass of deuterium? 2, then plus 16. So it is 2 into 2 is how much? 4. 4 plus 16 is 20. The molecular mass is 20 into 100. So if you see mass percentage of deuterium in D2O in heavy water is how, what is the value? Is 20%. So this is the mass percentage of deuterium D in heavy water. Let's see one more question. You can pause and you can solve it. Calculate the mass percentage of carbon, hydrogen, oxygen present in one molecule of glucose. Before putting all the values in the formula, first you find out the molecular mass of glucose. Glucose is C6H12O6. So we have 6 carbon into its atomic mass is 12, plus we have 12 hydrogen, its atomic mass is 1, plus oxygen, we have 6 oxygen, its atomic mass is 16. So if you solve this numbers, the answer that you get is molecular mass of glucose is 180. Now they are asking what is the calculate the percentage of carbon, calculate hydrogen and oxygen. I will solve only for carbon, remaining you have to solve. This is homework, and you can, the answers you can comment down in this video. So mass percentage, first I'll find out mass percentage of carbon. It's given by number of carbon atom into atomic mass of carbon divided by molecular mass of C6H12O6 into 100. Atomic mass of number of carbon we have is 6 and atomic mass is 12 divided into 100. Molecular mass is 180. This is given by 40%. For hydrogen and oxygen, you can solve and you can comment on the answers in the comment section. Let's see one more KCET based question. A compound has 20% of nitrogen by weight. If one molecule of the compound contains 2 nitrogen atom, the molecular weight of the compound. So now let's see what's given. Given is, they're saying there's 20% of nitrogen. by weight. So this is the mass percentage. They have mentioned by weight, so it is mass percentage value. If they have given by volume, then this value would be volume percentage. Is that clear? So let's see, if one molecule, okay, they're saying only one molecule of the compound contains 200. So for number of atoms is 2. Okay, atom. So now nitrogen, what is the atomic mass of nitrogen? Atomic mass of nitrogen is 17. The molecular weight, so they're asking us to find out the molecular weight. Again, simple, the same formula. Molecular percentage of nitrogen is equal to number of nitrogen atom into atomic mass of nitrogen divided by molecular weight or molecular mass into 100. So if you move this molecular mass this side and mass percentage this side, it is nothing but molecular mass is equal to number of nitrogen atom is 2 into atomic mass is 14, not 17. Atomic masses of nitrogen is 14 divided by number of mass percentage of nitrogen is 20 into 100. So if you solve this, the answer that you get is 2 into 14 divided by 20 into 100. The answer that you get is 140. So the correct answer is C. Okay, if the next question, if the molecular mass of compound is 360, if this compound contains 70% of carbon by mass, then the number of carbon atoms. So again, the same formula, I will solve it directly. They have asked the mass percentage 70% is equal to number of atoms, and atomic mass of carbon is 12 divided by molecular mass already given, that is 360 into 100. So we have 70 into 360 divided by 12 into 100 is equal to number of carbon atom. So we can do this. We have 7 into 36 divided by 12. So the answer is number of carbon atom we have is 21 carbon atom. We have 70 into 360 divided by 12 into 100. So the answer is So answer is 21 carbon atom. Now, a most important thing students tend to forget, that is, if in the question minimum molecular mass, this term minimum molecular mass is mentioned in the question, then always consider number of atom as 1. Okay, if in the question, like now the actual formula for mass percentage of an atom is number of atoms into atomic mass divided by molecular mass into 100. If minimum molecular mass, this will be minimum molecular mass is used, always consider number of atom as 1. So let's see the formula. So number of atom as 1, molecular mass, minimum molecular mass. So write down the formula. Minimum molecular mass of the compound, you shift the keep molecular mass as minimum and number of atom as 1, and take minimum molecular mass towards the left hand side and mass percentage towards right hand side. So it's given as minimum molecular mass of a compound is equal to mass of the element or an atom into 100 divided by mass percentage of an atom. So let's solve this by one question. So now the question is, a compound contains 28% nitrogen by mass, the minimum. So they have asked minimum. If minimum they ask, the number of atom is always 1. So it's given by mass percentage of nitrogen into number of nitrogen into atomic mass of nitrogen divided by molecular mass. They are asking minimum molecular mass, so minimum molecular mass into 100. So if you solve minimum molecular mass, number of atom, we take it as 1 into atomic mass is 14, minimum molecular mass is there's a minimum molecular mass. So mass percentage of nitrogen is 28 into 100. So the minimum molecular mass of a particular compound is given by, or is 50. It is 50. If at all, always, if minimum molecular mass is there, always contains number of atom is equal to 1. Last question. A compound contains 3.4% sulfur by mass. It's minimum. Same thing. This is homework question. Same thing. Again, mass percentage of sulfur they have given. Find a number of atom. We know that is 1 because they have asked minimum. Find out minimum. Atomic mass of sulfur is 32 and comment down the answer. Hope you all liked today's video. If you have any queries, comment on in this video. In the next class we will learn stoichiometry, how to calculate and how it is defined. Thank you.